Good morning, Earth Science. Today I'm going to give you a little bit of a brief history on astronomy and the beginnings of astronomy as we start to move through and as you've read through about the sun. And I will post the PowerPoint too as well when we're done with this, okay? So let's talk about this. So geo and helios are the two words that you'll hear. And the reason is that geo means earth and helios means sun. So as you have read, helios means sun and centric means center. So you're going to see and hear two terminology, geocentric and heliocentric, and the history of those. And those two terminologies were based on our system and our universe, right? So one of the things that came up is that Earth a long time ago was thought to be the center of the universe. And why? Well, they didn't know that much about the universe. They didn't know the universe. All they knew is that they lived on this planet and that's all they saw. So when you review the PowerPoint, you'll also be able to see that how at one time, thousands of years ago, when philosophers started to study the universe, that's what they were looking at. So, about the 4th century BC, when we're talking about geocentric, so earth-centered universe, where they thought the earth was the center, Plato and Aristotle wrote and thought and pushed, and these were great philosophers and great thinkers of the time. When we talk about 4th century BC, that's before Christ. And so they thought that everything surrounded them. Earth kept everything that they saw when they looked out up into the universe was surrounding them. So Ptolemy, who was a student, kind of improved the model, right? He put planets and stars in there. Remember, for centuries, thousands and thousands of years, civilization was based on the stars, the angles, how they built their buildings, from New Mexico, or into Mexico, not New Mexico, but Mexico, into South America, China, all over the world. They based their whole civilization based on astronomy. So during Greek philosophy, where the great thinking minds of the time brought it up and started to think, well, hey, what's going on? Are we the center of the universe? Does everything surround us? But as time went on and people started to feed on other people, that's what was coming up. But then, as time went on, heliocentric became a new system. And what was, and what we know now, our galaxy, which is the Milky Way, surrounds the sun. So all the orbits, all the planets, all the dead planets and different types of, if you can live on it or not live on it, all are surrounding the sun. So the sun in our solar system, which is the galaxy, Milky Way, is surrounded by the sun. Okay? So the sun is the center. And who came up with that was Copernicus, right? All these unusual names, but it took almost 1,800 years to come up and move from geocentric to heliocentric. And he really introduced the idea. And as he introduced that idea, he died that same year. So remember of the time, what was going on at the time. And it wasn't state separated from church. It really was a rejected idea. And that's because the Catholic Church had a really strong hold on a lot of philosophies and a lot of things going on at the time. So people really didn't believe that idea, and people couldn't accept that idea, often that they do now, right? You push ideas and sometimes the first thing that happens is rejection, because it's such a outlandish idea. You're talking 1,800 years, people believed Earth was the center of the universe. And then this guy Copernicus Copernicus comes up and says, hey, listen, wait a minute. Maybe it's not the center of the universe. Maybe the sun is the center of the universe. So his idea was really, really rejected. Not until around 1600 did Galileo, who hopefully you've all heard at this time, he kind of found evidence to support that, right? And how did he find evidence? He had the first telescope. So he could actually look out into the universe beyond our planet and see that there were other planets. And so that was able to give him evidence. That scientific method again, right? You have a hypothesis that Copernicus came up with, an idea that was out there, and then it took another, 150 years to come up with the idea that, well, maybe this is true. Maybe we can develop evidence to show that this is true. And he used the first telescope to go ahead and develop that. So, what was discovered by Galileo in that time is that there were 4 moons orbiting Jupiter and not Earth. And so Venus went through phases like the moon did. And we will go through the different types of phases. When you walk out, hopefully all of you got to see the supermoon that was here last Wednesday and Thursday. It was massive. It was huge. Well, the moon goes through phases as we do too. We go through our seasons. That all plays a role in the moon, sun, and earth. And so what he found was Venus actually had its own phases. And so that was more evidence that developed. And then more students underneath him, more evidence that was going through that scientific method that we kind of had talked about a little bit, is that Brahe and Kepler were mathematicians. So anytime you develop evidence, it's not opinionated. It's all measurable. So anytime that you have data, you're able to measure it. And you had Brahe and Kepler, who were mathematicians, who were able to do that. And so they actually took 20 years to develop data, math, that was able to support what Galileo had already put out there. And so, but just like anything, when you're first starting out, you're going to have glitches. So what they also found in their observation over 20 years is that planets didn't actually go in perfect circle around. They actually kind of did like an oval shape a little bit, and that they weren't perfect circles. And what they called this was ellipses. Not eclipse, that's a different type of terminology, but ellipses. And ellipses means it's almost like an oval shape, not quite oval, but it's not perfectly circular either. Okay, so as you go through and we're starting to post stuff, please look through that. It's really important. That was the first discovery in the beginning of new thinking when it came to astronomy. And so as we start to move in and discuss the sun a little bit more, and that as you have already gone through the video of National Geographic, hopefully you enjoyed that because it had some really great information, and that you learned that now we know that the Galileo was right? Everything in our galaxy surrounds the sun, and what keeps those planets in those ellipses orbital, right? How do we not crash into each other? Well, that's the pull of the gravity from the sun. And so that's an awfully interesting evidence to support that, right? So that math can kind of back that up. Also, I thought it was an interesting fact. We often will look up into the sky and see this really orange sun, right? But what we found out is that the sun isn't orange, is it? It's actually white. Isn't that interesting? Because what do we know about white? If any of you have taken art classes, white is made up of all different kinds of colors. It all comes together. So I hope you enjoyed this video. I will continue to post videos and hopefully help you through the process and into my next. Have a good day.